My name is Ibrahim and welcome to White Wolf, where real engineering replaced empty talk. Today we are building the foundation of a modern VMware private cloud from the ground up. Let me show you the components I have here in my setup. A layer 2 switch, ESXi1, which is the main server, ESXi2 as a cluster, and ESXi3 as a cluster as well. And finally, one admin workstation, also called the jump server. These are the VLANs I created, each with a clean 24 subnet and a specific purpose, just like a real enterprise network. And all of these VLANs together are the core foundation for building the entire private cloud. I'm using a private class A range because it gives me a high address space, flexibility and room to scale as the environment grows. VLAN 99 is for management, ESXi, host management, vCenter, OpenSANs, firewall. The VLAN ED is for vMotion, so we can create live virtual machine migration. And the VLAN 60 is for vSAN, so we can create virtual storage. The VLAN 100 is for NSX transport, so we can have logical networking and NSX gateways. The VLAN 10 is for core services, as Active Directory, DNS, DHCP. Then the VLAN 50 is for WAN. The purpose is have internet uplink or logical WAN based on OpenSAN's next generation firewall. Then the VLAN 110 is for admin, workstation or jump host, so we can manage all this virtual machine inside of VMware. Now that I explained the VLANs, let me talk about the switch with the right mindset so you can understand. This layer 2 switch is not doing anything fancy. Its job is simple. Carry my core VLANs and give me a clean, stable foundation. This is how modern IT works. You start with a strong physical base, then you build everything else on the top as a software. The switch only handles the essential networks, just the basics. Management, vMotion, vSAN, NSX transport, and core services. Nothing more, it's just the backbone. Later, when I move to the VMware NSX, that's where the real power comes in. NSX will take over to all advanced networking inside VMware. It will create logical networks, logical switches, logical routers, all in software, not on the physical switch itself. Remember, this is the mindset. Start with strong underlay, then let software-defined networking takes you to the next level. So in simple words, the switch is the base, but NSX will build the modern cloud network. Now, let's move on to the ESXi hosts. I have 3 physical servers, and all of them are installed with VMware ESXi. ESXi1 is my main server. The main server hosts all core services that bring the cloud to the life, including the firewall, Active Directory, DNS, DHCP, and vCenter. These foundation services must run here first before the full cluster operates. Later, additional services like NSX and more advanced workloads can be added on the top of this foundation. ESXi2 and ESXi3 are additional hosts. They have the same ESXi installation. And just like ESXi1, they receive all the same VLANs from the trunk ports. These 2 hosts will support the main server and help share the workload. Later, all three hosts, ESXi 1 and 2 and 3, will join together as one VMware cluster. A cluster means they act as one big machine. CPU, memory, and storage become one shared pool of resources. This is where load balancing comes in. If one host gets busy, VMware can move virtual machines to another host. If one host fails, the other hosts keep everything running. This is the same high availability and load balancing that real data centers use today. Now let me explain how the trunking works, because this is an important part of the foundation. On the switch, I have 3 separate trunk ports. Each trunk port is assigned to one ESXi host. Trunk port 1 goes to ESXi 1. And trunk port 2 goes to ESXi 2. And trunk port 3 goes to ESXi 3. All 3 of these ports are configured as 802.1q trunk ports. That means each trunk carries all my core VLAN through one cable. Management, vMotion, vSAN, NCX transport, and core services. Because every ESXi host is connected to its own trunk port, each host receives the full network fabric. They all get the same VLANs, the same subnets, and the same backbone. This is what allows the 3 hosts to later form a cluster and act like one big system. So in simple words, each ESXi gets its own trunk port. All VLAN flow through those trunks. And together this creates the backbone of the private cloud. Now, let me explain the workstation, also called the admin or jump server. This machine lives on VLAN 110, which is my admin VLAN. On the switch, the port for this workstation is not a trunk. It is an access port. That means it only carries one VLAN, VLAN 110, because this device only needs access to the management side of the environment. From this workstation, I manage everything inside VMware logically, as vCenter, ESXi hosts, OpenSense firewall, and all the virtual machines. But here is the important part. Even though this port is access mode, VLAN 110 itself is only carried on the trunk ports to the ESXi host. Why? Because VLAN 110 will also exist inside VMware as a logical management VLAN. So VMware can use it to manage virtual machines and services, while my physical workstations uses the same VLAN from the outside. In simple words, the workstation gets VLAN 110 as an access port. The ESXi host receives VLAN 110 through the trunks. One physically, the others logically inside VMware. Before I end this video, I would like to explain something important about modern IT and the cloud, because many people misunderstand it. First, traditional IT. Traditional IT is the old way. You manage everything one by one server, one switch, one system. If something breaks, you fix it physically. It works, but it's slow and not flexible. Second, modern IT. Modern IT still uses the same physical hardware. Switches, VLANs, servers, and even storage. But it adds a smart software layer on the top that makes everything work together as one big system. And this is the key. Things that used to be physical like VLANs, storage, firewalls, and routing become software-defined and logical. They run in software instead of hardware, while the physical backbone stays underneath to support everything. Fixing the wrong cloud definition. Many people repeat, cloud is somebody else's data center. But that's not true. A data center somewhere else is still just hardware. It's not cloud by itself. Cloud is about the technologies on the top: automation, orchestration, APIs, software-defined networking, and running everything as one big pool of resource. For that, we can say that cloud rests on modern IT, sits on the strong physical foundations as backbone. Why we need a private cloud? We need a private cloud because physical IT can't keep up anymore. Managing real servers, switches, firewalls, and gateways takes time, space, and a lot of cables. It's hard to scale, hard to automate, and everything must be done by hand. In a private cloud, we move from physical hardware to software-defined. Now, compute, storage, networking, firewalls, and gateways all become logical, controlled from one platform. For example, vSwitches and VDS replace physical switches. We can create, connect, and control all networks inside software without touching a single cable. Gateways become logical, fully managed by ESXi, which also bring micro-segmentation. This means every virtual machine, network, and connection is isolated by default. Nothing connects unless we allow it, giving full zero-trust security. If a virtual machine is ever attacked, we can delete it and deploy a clean one from a template in seconds. It's like giving it a brand new secure computer instantly. This makes the data center faster, safer, and easier to manage. VMware, the bridge between traditional IT and the public native cloud. VMware Private Cloud is the real gateway to the public and native cloud. You can't just jump into AWS or Azure without first understanding how the cloud is built. All those big public clouds are based on the same concepts that start here in VMware. When we build a VMware Private Cloud, we learn the real foundation of modern IT: virtualization, software-defined networking, storage, gateways, and automation. That's exactly how AWS, Azure, and Google Cloud are designed. The same logic, just on a bigger scale. The public cloud was born from the same architecture we built here in VMware. vSwitches and VDS become the idea behind virtual networks in AWS and Azure. vSAN become the module for cloud storage. NSX and micro-segmentation become the base of cloud security and zero-trust design. vCenter become the idea of centralized control like AWS console or Azure portal. So, when you master VMware Private Cloud, you understand the real engine behind the cloud. There is no shortcut. You can't be a real cloud engineer without knowing how virtualization and software-defined systems actually works. VMware Private Cloud gives you that foundation. It teaches you how to build, connect, secure, and automate everything from the ground up. And once you understand that, moving to the native cloud becomes simple, because you already understand the logic that built it. This is the real path. Build the foundation, master VMware Private Cloud, and then move into native cloud with confidence. That's how you become a true modern cloud engineer. Always remember, the secret of IT is curiosity. Don't just repeat what other people say. Find your own path of learning. Always ask how things work and why they work. This is how you grow and become a real engineer. My name is Brahim, and see you in next videos where we will start implementing everything step by step. Thank you for watching and see you next time.